right. Hey, everyone. Today I am here again with Dan Purkat. He's Graco's Industrial Process Product Manager. In the last couple episodes, we've been talking about materials of construction for diaphragm pumps. So we looked at plastic diaphragm pumps, metal diaphragm pumps, the fluid section areas. So today we wanted to talk about the properties and applications with our pumps for the internals, the diaphragms, the balls, and the seats. So Dan, thanks for joining me today.
Thanks for having me.
So let's talk about these internal components then. So what materials do we offer for our internal components?
So generally speaking, when we talk about internal components, we talk about two different types of materials. We talk about thermoplastic elastomers, which is basically an injection molded component that's homogeneous. So from edge to edge, side to side, and it makes it one continuous unit. We also talk about vulcanized rubber. So basically it is what it is. Think of a tire. You have some rubber, some fiber, another piece of rubber, and then it's all melted together to form one unit, but it's essentially different components. So we look at, say, a vulcanized rubber, such as this Viton diaphragm, very flexible. We look at, say, this Sanaprene diaphragm, very rigid. Mm-hmm. This is a thermoplastic, top to bottom, side to side, all one unit. So that's typically what we look at when we're talking about different types of internal components.
Got it. Okay. And you said those are usually plastic injection molded, correct?
That is correct. We injection mold the thermoplastic, the TPEs, we call them here.
Okay. All right, sweet. So what factors do we usually consider when we start to select the best fit for internal components?
So first and foremost, what we look at is chemical compatibility. We take our application, what we're actually pumping in, we want to make sure that it's compatible with the material so it doesn't degrade over time.
That kind of seems to be a theme that we've been talking about, is chemical compatibility with everything.
Absolutely. I mean, that's where it all starts. If you don't have the right pump, you're going to have problems down the line, which is obviously we don't want.
Right.
So when we look at, for instance, if we're taking chemical resistance as our number one priority, some of the highest chemical resistant components are PTFEs or Teflons. We've talked about that in the past as well. And say a Viton, like I talked about with this diaphragm here, which is a vulcanized rubber product. But there are some secondary considerations as well. Abrasion is probably number one, as is in the secondary consideration.
Yeah, so like last time we talked with the metal diaphragm pumps, wastewater is one of our favorite applications for those pumps. And
one of our favorites.
A lot of abrasion a lot of abrasives in those applications.
Absolutely. So what we want to do is we tend to start looking at our TPEs, our thermoplastics at that point. As I showed before, this diaphragm is very rigid. It's very abrasion resistant for those applications that have a lot of abrasives, a lot of solids in them. When we look at those, we tend to look at a lot of the Sanaprene type materials. We like to look at Geolast, which is a little bit different material, but the same abrasion resistance as Sanaprene. And we also use a lot of Hytrol. This is also a thermoplastic elastomer. Also, temperature is always a consideration. Whether we're pumping heated or chilled material, it depends. It affects flexibility. It affects the durability that way. And also, we want to look at whether or not extreme ambient temperatures are present when we start talking about the temperature resistance of certain elastomers. And last, maybe not least, is cost. You know, some of these materials are very expensive. You take a vulcanized rubber like Viton, this material, it costs a lot to produce. Highly chemical resistant. You look at some of these TPEs, these are considerably cheaper. Okay. And if you don't need high chemical resistance, you might as well go for a lower cost alternative at that point.
Okay. When we're talking about temperature, heated or chilled products, where are those applications typically? Where would we find those?
You're going to see a lot of that. If not in food, which isn't necessarily my specialty, you see a lot of that in food. You also see it a lot in chemical processing. Okay. We see a lot of it in different, as far as we talked about those extreme environments. Think our friends in the north, Canada. It gets very cold up there. You need very flexible materials. On the flip side of that, think Australia, how hot and dry it is down there. You're talking ambience out in the field at 140 So you need materials that can tolerate that high temperature as well.
Got it. Okay.
You know, and generally speaking, the higher the chemical resistance, the higher the price. So when we make that cost, if you don't need that high chemical resistance, you might as well err on the side of less.
Okay. So right here, I have a product that we put together called our Materials of Construction Guide.
I know it well.
Yep. So it talks about all the materials that we offer, and then some checkpoints on the columns for availability, what seat ball diaphragm, and then what conditions it's good in. So if you look on here, PTFE, that thing's got X's basically all the way across. Maybe not so great for abrasion unless you do our overmolded PTFE. So why don't we just do PTFE for everything?
Great question. It comes up a lot, quite honestly. PTE is one of the most inert materials on the planet. It is basically tolerant to any chemical. The thing is, it is very soft. It is not abrasion resistant. So if there are solids present, you generally are not going to go with a PTFE. And because it is so chemically resistant, it is very expensive. So we don't want to just default to PTFE all the time because it's not doing the customer service to put a very expensive material in their pump when it's not needed. It really is kind of a balancing act here. You're trying to find the best solution for the customer based upon what's being pumped, abrasives present, temperatures, cost, and to get them the best solution you can.
Seems more of an art sometimes than a science.
There's a lot of tribal knowledge that goes into this, and there's a lot of nuance to it. And sometimes, to be honest, again, there's trade-offs. You may not find that there's one perfect material for your application, so you try to get yourself to that point where you're going to get the best durability at the best price.
Yeah. Cool. So let's talk about how we manufacture these, or how they're typically manufactured out in the field. So, when you're just looking at general manufacturing of these, diaphragm ball seats, how are they typically made, and then how does Graco do it differently?
So like I said, we've got two ways that this is done. We have vulcanized rubber materials that are typically dissimilar materials that are melted together. Then you have your thermoplastics, your TPEs. We injection mold all of our TPEs here, so that allows us to control the design and the quality.
And by here we mean our Riverside factory in Minneapolis.
Thank you for qualifying that. Yes, at our Riverside in Minneapolis. And what's nice about being able to control this quality is when we look at these diaphragms, the balls and seats that we make here, we can really minimize the amount of waste. And that helps us achieve the sustainability goals that we have at Graco. That's what it's all about, is minimizing waste and sustainability. And that allows us to do that. Yeah,
so we've been talking about diaphragms. Let's talk about those balls and seats you have sitting there too. So how are those usually manufactured, and do we do anything differently here?
So kind of the same way. If you look at this being a diaphragm seat, these are injection molded. Balls are a little bit different. This is a PTFE ball for a 1-inch diaphragm pump. These are made from rod, and we actually grind these into a ball. And there's a lot of companies that do this. We do it really, really well. And it's all about quality. It's all about minimizing the waste, which helps us keep costs down that we can pass on to the end user as well.
Are there any considerations, going back to our previous discussion with the diaphragms, are there any considerations we need to look at when we're talking about balls and seats? So we talked about chemical compatibility, abrasion, temperature, range, and price. Are those pretty much the same for balls and seats, or is there anything different we need to consider?
Yeah, so good question. By and large, compatibility of one is compatibility of all. So this is a high trill seat. It has the same compatibility and abrasion resistance as a high trill diaphragm. PTFE, same thing, very soft ball, but very chemically resistant. So we have to take those considerations into account. One thing also we do, there are some considerations when it comes to ultra high abrasion, ultra high viscosity materials. So we do offer metallics as well, stainless steel and aluminum seats, stainless steel balls if you have a very, very viscous material where gravity, you need gravity to work for you, obviously.
So the ball needs to be heavier than the material.
The ball is just heavier than the material. Yeah. That's exactly right. So we do have metallics available as well.
Okay. So what's the best method for us to go about specifying a pump? When we start taking the last two episodes we did with the plastic and metal diaphragm pumps combined with what we've just been talking about, how do we actually go about specifying a pump?
Yeah, so on the surface, this sounds very complex. We talked about the earlier podcast with the metal and the plastic pumps, and now we've thrown this into the mix. Mm-hmm.
There's a lot of components that are going into this pump.
A lot of components. Yeah. And when you think about the thousands of applications that are out there, you do need to specify them carefully. The easiest way to do that is to use the Graco Industrial Process Selector tool and our chemical compatibility guide. It allows you to look up the chemicals that you have, choose the best materials. They can then be input into our selector tool, and it will give you a part number of the most compatible pump for your application.
Okay. And I'm assuming if you're not able to get the right answer from those tools, probably just call into Graco customer support, tech support, to help walk you through that with a real life person.
Absolutely. We have some of the best tech support in the industry to help you with that.
Okay. So let's, I always like to bring it back around to the applications too. Mm-hmm. So it really affects, this is what the end user's looking at. Mm-hmm. They don't necessarily maybe not know the pumps, but they know what they're pumping. So we have a couple of our favorite applications: wastewater, chemical transfer and processing, and then petroleum-based products. How would you go about, and maybe what components would you put into those different applications?
Yeah. So if we think back to the earlier podcast, let's talk wastewater. We always lean toward a metallic pump. Let's think aluminum in this case. What we want to do then is we want to be able to specify some internal components that are very abrasion resistant. We know there's a lot of solid present, in some cases, some large solid. So we would lean toward, say, a Sanaprene. One of our thermoplastics, very rigid, very abrasion resistant. This will also handle some trace amount of chemical as well for, say, a chemical sump, which is a true wastewater application. Very, very common to see an aluminum pump fitted with all Sanaprene ball seats and diaphragms.
I'm assuming that's probably going to be one of our more economical pumps as well.
It is an economical pump. With wastewater being the consideration, you want to keep costs down. Absolutely.
Okay. So let's talk about the chemical transfer. So, it's more complex material.
Yep.
So how do we handle that?
So again, we would go back to it when we talked. We would generally specify a plastic pump, of course, because they're more chemically resistant. And then we would look at something like a vulcanized Viton material. Very, very chemically resistant. This does have some abrasion resistant properties as well, but it's still a relatively soft material. And we have the option, here's a Viton ball and seat as well. We can do all Viton ball seat and diaphragm to give you some top-notch chemical compatibility. In the most extreme cases, we then move toward a PTFE.
Okay. And then obviously we do a lot in the petroleum market. So what does a typical pump for that look like?
Again, as we spoke before, petroleum, we're generally going to specify a metal pump. And we could look at something in a Buna, a nitrile type material. That's a rubber as well, much like Viton, but it's nice. It's much less expensive, fully compatible with petroleum-based products. We also very often will specify Hytril. Although it's not a rubber product, it's perfectly compatible with most petroleum-based products out there. It's nice also for waste oil because it's abrasion resistant again, and we know there's going to be particulate present.
Okay. Awesome. Well, Dan, this wraps up our session unless you have anything else you'd like to add.
No, thanks for having me. I appreciate it.
So thanks for spending time with us, talking about metal diaphragm pumps, plastic diaphragm pumps, and then today specifically on the components. So make sure you visit us at Graco.com and follow us on LinkedIn. Have a good one. Bye.